The last concept then is taking what we did previously, finding all zeros and all asymptotes when we've got a shift. And the process is going to be the same way, where we're going to find the distance between characteristics. We'll take a known starting value and then put it in the form starting value plus the distance times n. So here the half in front of the x means that for every pi units, there is 1/2 of a cycle completed. And if I look at that in terms of a period, I know pi over b is going to be my period formula for this tangent function. So pi over 1/2, which is going to be 2 pi for an entire period. So the new period is going to be 2 pi. That is going to be the distance between each of my asymptotes and each of my zero values. So what are the new asymptotes and what are the new zero values? So we'll take the same process that we did before. With the new asymptotes, we are going to set what's in the parentheses equal to pi over 2. And for the zero values, set the parentheses equal to 0. And the reason for that are the two starting values on my original trig function, my original tangent function, was pi over 2 for asymptotes and 0 for zero values. I could do negative pi over 2. If I wanted to, I could do 3 pi over 2. Any of the original asymptotes or any of the zero values would work. But just for simplicity, let's use pi over 2 and 0. So for all asymptotes, I need to find a starting asymptote for this function. So I'm going to set whatever's in parentheses equal to pi over 2. So inside parentheses, I've got 1/2 x minus 3. So 1/2 x minus 3, and I'm going to set that equal to pi over 2, and I'll solve. So I'll add 3 to both sides. 1/2 x is equal to pi over 2 plus 3, and then I'll multiply both sides by 2. So multiply this guy by 2 and multiply that guy by 2. X is going to equal to pi plus 6. So this pi plus 6 is an asymptote. And I know that the distance between asymptote is 2 pi from up here. So my format that I'm going to do is x equals the starting value plus the distance times n. So my starting value is going to be pi plus 6 plus my new distance. So the first blank is starting value, the second one is the distance. So there's my equation for all the asymptotes. Yeah. So what are the zeros? Do the same process, but this time saying the parentheses equal to 0. So 1/2 x minus 3 is equal to 0. Add 3 to both sides, and then multiply by 2. X is going to equal 6. So in the format, x equals the starting value plus the distance times n. The starting value is 6. The distance is 2 pi. So that's going to represent all your zero values and all your asymptotes. We've got one more here. Find all the asymptotes and zero values for the following tangent function. We first need to find out the distance between each asymptote and the distance between each zero. And that's going to be the period. So I'm going to start out by saying pi over b for tangent. My b value is 3. So I've got pi over 3, which is going to be my period, or the distance between each zero or asymptote. So for all asymptotes, we're going to start by taking whatever's in parentheses and setting it equal to a known asymptote, which is pi over 2 from our parent function. Solve for x, and then divide both sides by 3. So right here is my starting value. And if I write it in the format starting value plus the distance times n, all asymptotes is going to be pi over 6 plus 2/3, that's my starting value, plus my period, which is going to be pi over 3 times n. So that equation represents all the asymptotes. For all the zeros, we'll take a known zero for tangent, 3x minus 2, which we know is going to be 0, and we'll solve. So there's my known value. I know the distance between each is pi over 3, so the equation for all zeros is going to be 2/3 plus pi over 3n. And then the final point that I've got at the bottom is if you're going to sketch a transformed function, you do the period first, then stretch, shrink, then shift. So you do your transformations before shifting.